All right, so for those of you who don't know who we are the Society for Ecological Restoration U of I chapter. We're a new club here on campus. We just got our official recognition last week. With us today is Brian and Pam Robertson. They're a pair of landowners in Deary, about 20 miles, 30 miles west here or east of Moscow. They've been performing a pretty extensive restoration on their property, and they are here to talk about that and share us with their experiences. So, all right.
Okay.
Turn it over to you.
Okay. Thank you, Garrett. Thank you very much. I'm glad you found us.
I am too.
Yeah, we didn't know that SER even existed until 3-4 days ago when Garrett called and said he found us from that Land Trust Alliance, which we're in the process, since we're doing all this work, we're in the process of putting the project and the property into a conservation easement and to protect it, because we've done a lot of work, spent a lot of time on this. 2 or 3 years ago, we basically knew nothing about, we knew the stream was broken. It's been broken for many years, since we think mid-1930s. So it's almost 100 years since it's been destroyed, I guess you'd want to say. As the hydrologists say, it's disconnected from the floodplain. We just knew it as a ditch. And as you can see on this first slide here, why fix this valley? Well, there was a ditch that was about 20 feet wide, 12 feet deep. And we'll show you a little video here in a second of before the project, and that was draining the entire valley. And it used to be a floodplain and a wetland, and sometime in the 20s or 30s, logging operations destroyed that, and a subsequent ditch was formed. As we learned more about stream restoration, Pam came across a thing on the Federal Register published in 2011, a study that Fish and Wildlife Service did in Latah County. They came up with this number that was staggering, that since 1890, 97% of the wetlands in Latah County are gone. And they've been replaced with agriculture, grazing, and hay ground. And out where we are, you really can't grow anything except hay, and you get one cutting a year. So economically, it's a poor value area for agriculture. And early homesteaders out there, they had to have a tough time surviving because our growing season is just too short. This 12 foot deep ditch also, as in draining the valley, it was just like, we call it the toilet flush, because you get rain or big snow melt or rain on snow, boom, the water goes by about 100 miles an hour, and a couple hours later, that's the end of the water. It's gone. None of it stayed on the ground, at least on our ground in the valley. Water tables in the area have been going down, and we have numerous dry wells. Our neighbor down the road a ways, last year, 2021, drilled a well 400 feet deep and hit dust, dry hole. So about 3 months later, he got the driller back and he drilled another hole about 100 yards away, 505 feet deep, and dust. So the guy's got almost 1,000 foot of drilling and he has no water. And another neighbor also drilled a dry hole several years ago, probably 15 years ago. And we were kind of shocked because our well, knock on something, is so far holding out. We have an old well on the property that we use for monitoring. And when We know when they drilled that well from the driller's report that water was at 12 feet. The driller hit water at 12 feet. And this is back in the 90s. And we've got it up to a little 8.5 now down to water. So we've put almost 4 feet of water back in the valley with this project, eliminating the ditch. Okay, this is the valley from looking northeast. Our property line, I don't know if the mouse will work here, if you can see that or not. We can see it. Oh, there it is. Yeah, our property line's right here to the west. That's our neighbor over here. This is the 12-foot deep ditch running up that valley. And we have a half mile. About here is our north property line. So I'll start this video. It's a drone video. All these drones were taken by a fellow named Andy Hill, who works for Anabranch Solutions, which is based out of Utah. They're a process-based restoration company that has helped us out ever since we started this. So this will just give you an idea of what it looks like going up the valley. This was all a wetland, one floodplain at one time. And we'll back up here in a second and we'll tell you why that ditch happened. We have a couple of ponds up here that were built in the early 90s. Those are called HIP ponds, HIP, Habitat Improvement Ponds. We did not own the property then. It's a program through Idaho Fish and Game that built those, a cost share with landowners. So this is going up to the north end, and right about here is our property line. Okay, and there's the drainage. And the other side of this ridge up here is Palouse River drainage. We're on Clearwater River drainage. So our water goes into Little Bear Creek, goes into the middle fork of Big Bear Creek, which runs down to the main Big Bear, which comes out in Kendrick by the high school, and it goes in the Potlatch River. Potlatch River hits the Clearwater at Arrow Junction, and then Clearwater the Snake at the confluence in Lewiston, and then on to the Columbia. Let me back this up and we'll show you why the ditch formed. In the early 30s, they built a spur rail which ran right along, if you follow the pointing hand there, that spur rail bed went right along there and on up the valley. And then when you get to the upper end of the valley, it kept going. You can see a little piece of where it was, but it went clear up into here. And all this country up here was logged. Potlatch Corporation logged it then. That is still their property. In the last 10 years, you can see how much is clear cut. But I want to say 80 to 90% of our 3,600 acres drainage is being clear cut. And this is another reason we're having these flashy water flows, because when it rains, we get it quick because there's nothing back there to slow it down. But anyway, that spur rail was built and they built it without regard to any kind of drainage. And they just built it. It was temporary, about 2 years. They had all the logs out. They take the logs out, then they pull the rails and they move to the next valley and they build another spur rail and they log that out and they pull the rails and they go to the next valley. And literally every valley from here to, boy, I want to say clear to Rorschach Reservoir and beyond. You get on the other side, headquarters side, and over there, same thing. They put in spur rails everywhere to move big timber out. And the water then, they went right up the middle of this valley. And so then the water can't spread out anymore because there's this berm in the middle of the valley. So the water comes down and it starts running in what they call borrow ditches, where they just pull the dirt up to make the berm for the rail. And then the water just gets in those ditches. And once it gets in a ditch, it's off to the races. And you got massive erosion. And when you drive around anywhere in the Northwest, just look at valleys. Look for that flat valley that's got a ditch in it. So if you see a flat valley with a ditch, something has gone on to make that ditch there, because that was probably once a wetland. The ditches aren't natural. They're man-made, man-created, I guess. And so anyway, we'll go to the next slide once I get out of this. There we go. In 2003, we knew something was wrong. And so we contacted Barry Cummings, who was just, I think that was his first year as being a fish and game officer. We asked him if they ever trap any beaver, could we have some beaver to build some dams and slow this water down that's coming down this ditch? And he said, yeah, they do. In fact, have a couple of problem beaver over on Nora Creek. And so, I don't know, it was not more than a couple of weeks later, he called and said, I got a pair of beaver for you. And so he came right over with the beaver, put them in, and 2 months later, this is the kind of thing we were starting to see up the valley. And let me tell you, this is cheap labor. You don't have to pay anybody, no workman's comp. There's no, it's nice. Beaver, we're big beaver believers. So once you do the heavy work, put beaver in there, they know how to fix things. And then this was, okay, so this was, I didn't put a year on it. This was about 2000, this was 2003. So this is 2010. And this is one of their dams that they had. And this, behind this one, there's about an acre of water build up. And that's probably 3 feet, 2.5, 3 feet deep. But shortly after this was taken, we had a big rain. For days it rained. Water came up and just blew this dam out. And the other issue, because this valley has been dry so long, it's not growing beaver food. Beaver like aspen, cottonwood, and poplars, willows, those 4 are beaver food. And there was we had 2 willow plants in the whole valley. That's all that was left. And willow is an interesting plant because beavers, they have this relationship with willow because they can cut it down to nothing and willow just keeps sprouting. And they have a constant, it's their grocery store. They get deliveries constantly. And you say, oh, these beaver are going to eat themselves out of house and home. Well, they can if there isn't enough willow. But if there's enough willow and you have the ground wet, and those willows will keep going, and the beavers will survive, and they keep the valley wet. Taking beavers, this is veer off subject for a second on beavers. In about 1800 around here, all the beavers were removed from all the drainages by trappers. European trappers. Felt hats were big in Europe. And there was a contest to see who's going to get the Pacific Northwest. Is it going to be England and the Hudson Bay Company? Or is it going to be those Americans? Are they going to take it? Well, the Hudson Bay Company, they sent every trapper they could muster to the Northwest. And they said, make this a beaver desert. We don't want to see a beaver because when Americans come here, they're going to go, there's nothing here. The beaver are gone because at the time, beaver were the currency at the time. If you needed to buy something, you bought with beaver pelts. And anyway, so this whole area, and we're talking from California clear up into Canada, you know, Utah, Colorado, beaver were eliminated. There have been some figures that say that before 1800, there were maybe 300 million beaver in the Western United States. That's more than the population of people in the United States. 300 million beaver. And what they did, they kept all these valleys wet. So they had food to eat and the aquifers charged. Keeping water on the ground longer recharges aquifers. People are always worried about the aquifer keeps going down. We have drains cut down nearly every valley. And it's not just here, it's in this country. And if you saw the story yesterday, the day before, about New Orleans is having trouble because the Mississippi River flow is down. And it's down, and now seawater is encroaching, sea levels coming up, river levels going down. Now we're getting salt water up to New Orleans. And so the Corps of Engineers, they're rapidly dredging the Mississippi to try to get the water to flow back down there and push that seawater out. But part of the reason is that aquifers are dried up and there is no upwelling of water anywhere. It's all in ditches and it's just drained. We didn't know what to do with this valley, and we worked with a lot of people. We had done some logging because we had a whole bunch of diseased trees on the timbered side of our property. And we asked the forester that worked with us, do you know anything about stream restoration? Well, of course, he says, I don't know anything about stream restoration, but you're working with NRCS people on a cost share program called EQIP, which stands for Environmental Quality Incentives Program, which is cost share. It's not free money or granted money or anything. It's money that's there that if you put in some money, they will put in some money and you can get a project done. Well, so we were working with them on forestry. So we went back to them and asked if they knew anything about stream restoration. And they said, well, that's kind of not our thing for here. We're in Moscow and Pullman, and this is wheat country, and we're really ag. But they turned out they did have some practices that they would reimburse for fixing streams. And so we worked with them and got into that. They had people come out, and the first thing we decided to do is we're going to put ditch plugs. We're going to plug this ditch with dirt, make a dam every so many feet, and that will back up a pool, and then it'll run down to the next pool, and it'll back up another pool and run down to the next pool. But the problem was that our property line, that first slide we showed, for the video slide, at our property line, you have to let the water down 12 feet because it was in a 12-foot ditch. If you take it out of the ditch, you put it up 12 feet higher. How do you let water down 12 feet in a matter of a few feet? That's a waterfall, and that doesn't work. And so there was all sorts of schemes and stuff come up with, and one of them was rock and concrete, and down at the bottom, yes, we can route this water through these structures, and kind of looked like the bottom of Bonneville Dam. And I said, that's not appropriate for here. We didn't like that solution. And then one day, a guy that we worked with, he'd been out many times. He's from NOAA. His name was Bob Reese. He just retired this past year, I think. Yeah, he did. But Bob brought us two papers. He actually gave them to Pamela, who we worked with at NRCS. One of these papers was called SEM, which stands for Stream Evolution Model, and was by a guy named Brian Clure and Colin Thorne. And if you just look up SEM on the internet, you can download this paper right there. And this is kind of got us on the way to fix the ditch. And stage 0 is reference to not a way to fix the ditch, but it's the state of the land. And it's the state of the land pre-European contact, which nobody has seen. There's nobody living that has seen a true stage 0 where there's a ditch running down. But at one point it used to be stage 0. And then through these stages, and there's some little sub stages too, it's the evolution of an ecosystem in a valley, basically. And so I would recommend looking this Chlorine Thorn paper up and download it and read it. It's pretty valuable. Once we had that information, Bob also gave us another paper, this one right here, which is a research paper by a fellow named Paul Powers and his buddy Matt Helstab. Sue Nisgoda, she's from Gonzaga University. She was the one that made sure the grammar and everything was correct in this paper, and it was formatted right. Paul and Matt, they provided the material. She kind of put it all together and it made sense. But what this is using LIDAR, which is a fancy term for an airplane flying over, shooting a laser beam at the ground. And that is amazing technology. It's shooting a laser beam at around 150,000 kilohertz per second. And the high resolution like had been shot. We were lucky. The Nez Perce tribe had shot a lot of the Clearwater drainage in 2016, and our property happened to just slip in there. And so this LIDAR data, which is free, you just have to find it. And that was another journey we went on, finding the data. But this data is free, anybody can use it. And in using LIDAR, that laser shoots on ours, there's 8 hits per square meter. So you got a square meter like so, there's 8 elevation points in every meter. So it's really detailed. The type of LIDAR that they used ignores vegetation and it goes directly to the earth. So it can be covered with brush 20 feet deep. It ignores that. It hits the earth and gets a reflection back. So anyway, Paul Powers, he is a kind of a ArcMap. Has anybody here ever used ArcMap or in the program, GIS programs? Okay. If you've used ArcMap, then you want to look at Matt Helstab. He designed a tool for ArcMap that does what these guys do, and we'll show you that here in a second. And you can get his tool if you just search the internet. You've ever heard of a website called GitHub, GITHUB? You search GitHub, just put GitHub Matt Helstab, and you'll go to his page, and he has what's the tool that goes in ArcMap. It's called GLLREM, which stands for Geomorphic Grade Line Relative Elevation Model. And this does kind of some unreal stuff. And neither one of these guys has ever set foot on our property. But once they had the LIDAR, 2 or 3 hours later, we had maps, design, all this stuff, and it was all done through this tool that Matt designed. This is a bare LIDAR view of our valley. And if I can find the mouse here, let me get my glasses on. There it is. This is called hillshade mode. And I want to show you right up here, if you follow the pointer, that's our north property line. Here's our west property line. And this is the ditch. And if you look really close, the old rail spur came, this is the state highway now, which didn't used to be there. The old rail spur came right here Right there, you can see that little groove right there? That is one of the borrow ditches for building the berm. And so this rail bed went right up through here, right through here. You can still see a little bit of it right here. This is a road. This is not the old rail bed, but the old rail bed's right there. And so you can see where water goes. It goes to that berm and follows it down and cuts a ditch. And if you follow this up for 3 miles, 3.5 miles up this valley, it's the same thing. You see this old rail berm, and there's a big ditch for that length. Anyway, this was amazing to me because this is what the bare earth looks like. There's no vegetation on it. This area over here to the east, this is all forested over here, but you don't see a tree, you just see the contours. But there's data with all that. That's a picture. There's this data, which I forget how many thousands of lines of data, because he has an Excel file with all this data and all these columns, and there's like, I want to say 12,000 lines of data. And I don't know how all that works. Those guys do. Okay, so this is a couple hours after we sent him this data. This is one of the maps he sent back. And geomorphic grade line, GGL, this program kind of makes a best guess of the valley, and he took 3 miles of valley and basically averaged the grade line for the whole valley, which is 1% for us. And then with all this data, he can make these colored maps. And I don't know if you can see that very good. Yeah, you can see that pretty good. The yellow is high, and this is this is decimeters. Okay, decimeters. So correct elevation is light blue, baby blue. And you don't see too much baby blue, do you? It's mostly high. And he filled the ditch with a crosshatch, but that ditch would be in the minus 34 decimeters and greater for depth. And it would be pink, but he filled the pink just to show us what needed to be filled there. But his recommendation for the project was this red line. Was the program showed them that's what we should cut of our valley, and which we stuck to that pretty close. A couple of things we changed, but basically that all was cut. And down here we had 12 foot. This was cut 12 feet, probably nearly the height of this ceiling that we cut down because that's how deep the ditch was. And so we lowered the valley so we didn't have to lower the water. So now the valley's been lowered, so the water meets our neighbor's property down here at the correct elevation, which was 2,773 feet. Anyway, this is amazing too. I didn't put these on here, but each one of those transects across there with the elevation on it, those are all 40 feet apart. He can make transects every foot through the valley, and then he just draws a little box, a little polygon around that transect line and says okay, and it gives you a cross section of the valley. And something else we learned, if you're into stream stuff, which we didn't know, they talk all the time, well, that's valley right and that's valley left. Valley right and valley left. And it's always when you're facing downstream. So if you're facing upstream and someone says it's valley left, it's not over here. You got to face the other way and it's over here. So just remember, you're facing downstream, valley left, valley right. So we had a lot of valley right here because flow is from top to bottom, north to south. We had a lot of valley right. It was about 25,000 cubic yards of dirt, which is a lot of dirt. And that was taken back up to the north end, transported back up, and filled ditches and leveled the playing field, so to speak. Okay, this is, excuse me, this is another video. This is from mid-project, about the center of the project, looking southwest. Okay, so if I go back to the other slide, the drone is sitting, okay, there we go. The drone is sitting probably right about here. Okay, and looking this way. Okay, so this is a flyover of the 12-foot ditch. Whoops, didn't want to do that. We'll do it one more time. I wanted to stop it right about here. Why does that do that? I did click the wrong thing. Okay, let's try it one more time. It doesn't want to stop it. Maybe space bar. No. Okay, so we'll just do it from right here. If you look at, there's some old, these are called relic channels. There's some old channels in here before it falls off into this 12-foot deep ditch. And if you follow these channels across and look at the discoloration on the grass here, you can see that this used to run across over here, and then this used to flow back. And you can see old channels barely visible over here. Okay, and this has been farmed for since probably the early 40s, late 30s, early 40s. This has just been a hay field, and they've used it for some pasture ground. But this ditch got formed, and then all the water in that valley now drains to that ditch. So no water stays on top. And once it's in the ditch, it's just gone. Okay, we'll do the flyover here, and I won't fool with it anymore. So this is going to fly over the ditch. It's going to get down to that south end. He's going to turn around and point back to the north. And when he points back to the north here, you'll get a good view of up valley, and we're right over that 12-foot deep ditch now. And what we did, we cut this side down over to about that line. So we lowered this, we left this alone, and we left some vegetation in here, because this was just about, some of this was just about correct elevation anyway. And so all this dirt you see on this side over here was moved back up to the north end and used to fill irregularities up there. Okay, and this is another kind of the same thing. It's a little different, but you can get an idea how deep that ditch is. And it was also, somebody had gone in over the years and bermed up the ditch even, because at high water, that ditch would get completely full, but somebody didn't want it spilling into their hayfield. And so you could see where they had took a dozer or something and burned it up so it couldn't get in there. Okay, we'll go to the next slide. Okay, here's a grading in progress drone view. This was taken by Carl Meyer of Palouse Land Trust. And This area here, you can see has been excavated down and the ditch filled, which has leveled this out. And they still have this much more to go, plus some up here. So this was about 1/3 done on the project, I would say. We started grading on August 3rd of 2020. And what do you do? What do you use to do this grading? It's an excavator with a 4-yard bucket. They use 2 articulated 30-40 ton dumps, which carry around 25 to 30 yards of material each time, and 1 dozer, D6 size. So the trucks would get dirt down at the south end, they'd go to the north end and dump. And so we started cutting at the south and filling at the north, and we gradually met in the middle. Okay, so here's a shot on the right here, showing how it looks after grading. And one of the first things we did was seed it with native grasses. And so you can see it's just a big parking lot. And then for surface roughness, something for the water to hit, run into, rather than just racing down through there, we put logs over the entire surface. So you can see that, and if I had to do it all over again, which I hope I don't have to do, I would probably put at least twice as many logs. And that's what it looked like after the wood was on the surface. And this would have been late September 2020. So about 2 years ago. Okay, November 2020, we had the first water start. And I'll show you where the old ditch, right? If you follow the arrow, the old ditch was right here. All the water in the valley was in that ditch. But now you can see water's up on top. It's across the valley. And it's going a fraction of the speed that it went in the ditch. And so more time on the ground means more water in the ground. Okay, revegetation. This is something we had to do, and I wrote on there a tough row to hoe, because if someone were to ask me what's the toughest part of the project, I would say the revegetation. And this particular project required that massive cut to lower that valley. So that entire surface had to be revegetated. Well, we did seed it, but we also planted plants. And we kind of contracted with PCEI, which is Palouse Clearwater Environmental Institute. They're here in town, out Polk Street out there. And they have a lot of AmeriCorps employees, volunteers. A lot of them are students here. And they put in around 20,000 plants so far. And they're going to be planting 6,000 willows next spring. And then hopefully they're also writing a grant for the Pacific Coast Salmon Recovery Fund to give us another 6,000 willows for 3 more years. So we want to saturate the lower end. So that's their crew out there on a rainy day in April of this year. Later on in the year, we had Anabranch Solutions, which I mentioned. Andy Hill works with them. This is his crew. Andy flew the drone flights. We were able to score 3,000 willows. That's a long story, I won't go into it. But we were able to score 3,000 willow poles for free with someone that didn't need them anymore. And at $2.25 a pole, that was pretty nice. So we had Anna Branch come in, and they did some BDA work in some areas that were incised a little bit. And this was in June. We had record rainfall. This was this June 12th or 13th of this year. Never seen water like that in June. And so they came in and built some BDAs and planted these coyote and Pacific willows, about 3,000 of them. And we need a lot more willows. The area you saw where that cut was, that flat table, that's only about 5 or 6 acres. It's not that big, but it just swallows up plants like you can't believe. You know, you need a lot of plants, and we're going to try to get a lot more in. We've had quite a few tours of the project. This tour was a pig tour. Yeah, it was, pig, NOAA, pig. It was people from NOAA down in Boise at the main office. And pig, if you don't know what the pig group is, it's a local group of, well, kind of like you guys, interested parties or agencies in stream restoration. And it stands for Potlatch Implementation Group. And they're here in Moscow. And they took a tour, I think this was May, they came out. And we have tours all the time that people say, hey, can I come out and see your project? I want to walk it. I want to touch it and feel it. And I was talking to Garrett, and you guys, if we can set something up, you guys are welcome to have a field trip too. Oh, I did put on here another item. If you want more information about stage 0 and what it is and the research behind it, there's a website. It's there, stage0riverrestoration.com. And they have lots of, under their resources section, resources tab, they have so much information. I don't think you can live long enough to digest it all. It's a lot. Okay, here's the people that were involved with our project, starting with the NRCS and their EQIP program. And this was right from the local office here in Moscow. Paul Powers, who did the LIDAR work and the stage 0 design, he is a fish biologist in the Deschutes National Forest over in Oregon. Siuslaw National Forest, a fellow by the name of Paul Burns, he helped us out tremendously with implementation. He's the doer. He knows the equipment you need and the whatever. NOAA, they gave us advice till no end, and they still do. We talk to NOAA people. If we have a question, we have them speed dial. NRCS has a technology center over in Portland. They helped us out. Idaho Fish and Game Department, they sent a guy, Don Jenkins, his name was. He moved down to Rupert, or transferred to Rupert, but he came out to look at our project, and about a week later, he says, this is a great project. We had a check for $5,000 in the mail. Just like, great project, thank you. And we said, no, thank you. Fish and Wildlife Service up in Coeur d'Alene, the Coeur d'Alene office. We were Brittany Moreland. We worked with her, and she liked our project so well. She says, could you guys use $25,000 to buy plants? So we said, certainly. So it was just like the lotto time or something. We couldn't believe it. Latah Soil and Water District, they came out when we first started even thinking about this, because they do projects. East Fork of the Potlatch River right now, they have several projects up there going. And they came out and looked at our project. They work on granted money. They have to write grants to get funds to do projects. So we said, well, how long will that take? And they said, oh, 3, 4, 5, 6 years. You never know with those grants. And you never know if you're going to get approved or you're going to get turned down. And if you get turned down, you just do it again the next year until you get something. Well, we looked in the mirror and said, I don't know if we're going to live long enough to see anything happen down here at this pace. So that's when we went back to NRCS and found out about this EQIP program. And yes, we did have to pay money out of our pockets to do this project, but their cost share is excellent, very good. So it made it affordable for us to do it. Idaho, once we got the project done, the Idaho, there's an office called Governor's Office of Species Conservation. They became very interested in the project, and they have had 3 or so tours out to the project. PCEI, they've written a grant. We got a grant from PCEI's work from the Department of Environmental Quality, Idaho state grant. And they was for plants that they planted last year. And these new willows are going to plant in the spring. They got a little bit of money left in that grant to finish this spring. Anabrandt Solutions, they do our monitoring. One of the requirements of doing a project like this is you have monitoring. So someone independent of the project making observations and recording those and writing a report. And that's Anabrandt Solution. We work with Nez Perce County. They are the ones that have the LiDAR data. And there's also, used to be not so good just a couple of years ago, but there's a site called IdahoLiDAR.org. And all LiDAR in the state of Idaho that's been done is on that website, and you can download it from that website. So if you're an ArcMap person and want to fool with LiDAR data, you don't have to buy it or get out your credit card or anything else. You just go to IdahoLiDAR.org and pick out what you're interested in, the area you're interested in, and you can download that. And then the last item in here that's important to us was that the NRCS EQIP program allowed us to be that we were the contractors. So we kind of like that because we could pick and choose who we wanted to do the work. There was no bidding. There was no, NRCS is federal, but they didn't say, oh, wait a minute, you have to follow all the federal rules on bidding and all this stuff for the jobs. We could pick who we wanted to. And we picked all local people to help the local businesses in the area do the work. So, and plants were purchased from all the local nurseries. So that brings me to the last slide. And anybody know what animal that is?
Is that elk?
Elk, that's a good guess. Yeah, that's an elk. Has anybody ever seen an elk like that? I call it palomino. It's not anything the color of an elk, but it's a condition called leucism. Leucism, I think. And it's not albino. It's not an albino. People say, oh, that's an albino elk. It's not albino. It's called leucism. And there's another one running around our place that is a little smaller and we think is her calf, maybe. It's a genetic condition. And so that's pretty, you can spot her a mile away because boom, here's this white animal out. And they say that that is not good for elk because they're advertising, waving a white sheet. Here I am. But anyway, so we want to thank you all for coming. And if you have any questions, feel free to ask away. You want to see any slides again, or I would say go ahead and look up that Paul Powers paper and the stream evolution model by Clure and Thorne. And if you're interested in stream work, you need to kind of be familiar with, especially that SEM model, because that's what people are kind of using now. And they have, and that's Matt Hellstab Stage Zero tool. It's complete instructions on that GitHub too on how to use the tool. But you got to know how to use ArcMap first. So you install that tool and it does its magic. So, okay.
What has the reaction from neighbors been?
Okay, so that's a good question, Garrett. When you do this work, you have to get a permit. In fact, in Latah County, you have to get 3 permits. And one of those is called a 404 permit through the Corps of Engineers. The second one is a permit through the Idaho Department of Water Resources. And the third one is that we didn't know about till the last minute is a FEMA permit. And go back to a slide here. Okay, so on the FEMA flood map, and you can look this up on the internet. On the FEMA flood map, they have this a line drawn around right about here. And they say that's a flood zone. And we said, yeah, it's the middle of a wetland, it ought to be. And so all you have to do is you have to have an engineer sign a form that says this project will not elevate the water level any higher than it is now. And they have a level that they pull numbers out of the air. And high water line is here. If you're going to do a project that raises the high water mark to here, you're going to have to do mitigation because you're causing more flooding. Well, we were actually lowering the whole valley. So we actually lowered the water line. So we didn't have to do anything with that. The Corps of Engineers permit, we were really worried about it. We were going, oh God, these federal permits, piece of cake. You just fill it out and send it in. They never asked a question. Takes about 90 days to get a permit though. So if you want to start work in July, you better turn your paperwork in maybe in February. Give yourself a little cushion. So we got that, and and the nice thing about the 404 permit with the Corps of Engineers, they have now made it a joint permit with the Idaho Water Resources. So when you fill out your federal permit, you're also filling out your state permit. And basically, if the feds buy it off, the state buys it off, and you got your permits.
He wants to know what the neighbors thought.
Okay.
They had to sign.
Okay. On the Corps of Engineer permit, there's a spot at the bottom where you have to list all adjacent property owners, and they contact them. They send them the full packet of your permit, and then they ask your neighbors, if you want to complain about this, you have 30 days. And so one day, our neighbor over, got my mouse going, over here to the west, he drives in the driveway and has this big manila envelope. He kind of gets out of his rig and throws it on the hood of his car and says, "What's this stuff?" I said, "I don't know, what is it?" And then I saw, oh, it's from Coeur d'Alene, the Corps of Engineers. So it was his chance to comment. And so we kind of went through it with him and showed him what we were going to do. And when we said we're going to bring up the water table, because we're going to get rid of that ditch and slow the water down, keep more water in the valley, he was all for it. And we said, great, there's the phone number right down there. Go home, call that phone number and say you love it. And so And then our other neighbor to the north, the far north end up there, we told them that what we were going to do. They got the paperwork too. And we said, yeah, what we'd like to do is fill that ditch right to our property line. And when we do that, it's going to back water up onto your property about 300 feet. And they run cows over there. And so I said, you'll probably have water for at least a couple of months longer than you normally do. And they wrote a letter to the NRCS engineers and said, we give permission for water to be backed up on our property. And so once the Corps saw that and the neighbor to the west didn't complain, they said, here's your permit. And it was good for 3 years. It's good for three. They give you 3 years to get the work done. And we're still working on it all the time. We call it our senior project. Okay. So are you guys all undergrads or grads?
Most of us are undergrads.
Okay. So when you get to senior project and you get to be 70 plus, you can say, hey, I got a senior project. But what's really great is to sit here and see younger faces interested in this, because there ain't anybody else out there going to fix it. And the old folks are going away. So someone's got to pick up the ball and run with it. So we're hoping you guys are the next wave that are interested enough to get streams back to where they need to be. Okay, any other questions? Yeah.
Where exactly did you relocate those beaver to? Do you know if they stuck around?
Yes, they were around from 2003. They were around for 7 years. And in 7 years, they couldn't put enough water back in the ground to get food growing they needed. The main food in the valley at the time was alder. You'll learn somewhere if you take stream classes that alder is a weed in a incised valley, and they just come up. And beaver don't like them. I don't know if they taste nasty. They must taste nasty. I don't know. They don't like them. And the other thing we had a lot of in the valley was a hawthorn, black hawthorn, Douglas hawthorn, I guess it's called. They don't like that, but they like it better than alder. And most of that dam I showed, most of that's built with a hawthorn. And you can see this is hawthorn all back here. And this is hawthorn. You can see the fresh cuts right there, where they have just cut that down and dropped it in the water. And that's what they were using for the dam. But it isn't a food source they like. And this other stuff you see right here in the foreground growing out of the water, that's alder. And notice on the alder, it's not cut because they don't like it. They can't eat it. It's Brussels sprouts or something to them. They just don't like it. And so the food source in our valley was limited. They lasted 7 years, high water blew the work they'd done. But we think they just about eaten themselves out of house and home in that 7 years. But it was well worth it to see they transform a valley. And we're trying to get enough stuff growing where they come back in and we can take our lawn chair and sit out there and watch them work. We don't have to work. When you have to put the guys out there with the hydraulic hammers and that, you got to pay for that. Beaver, like 24/7, they just do it. And they got an eye. You can go out there with your laser rod and everything. That's a piece of crap. Beaver, they got the eye. They know right where to put it. So, yeah, they're interesting. They come to trickling water. If they hear babbling, trickling water, like a water leak or just water running over something small, they're genetically, they have to stop it. They have to stop it. And then they watch what it does to the water, and they watch where the water goes. So they don't like where it goes, they go over there and fix that. And they say busy as a beaver. That's an old term. And that's what they are. Let me tell you, they don't quit. And so if you can get beaver, if you do a project and get beaver in there, I'll bring this as politically incorrect probably, but I have a gripe with the Idaho Fish and Game that the state is one of them, spends lots of money on stream restoration, but they will not turn off trapping in streams, period. So they'll put $1 million of work in a stream, and then you go buy a $10 trap tag. And guess what the limit is on beaver in the state of Idaho? Anybody know the limit to take for beaver if you have a beaver tag? The answer is all you want. If you want 100 beaver a day, it's yours. There's no limit. And so finding beaver in Idaho is hard. And people, goes way back into the 1800s, where ranchers, if they saw a beaver in their creek, first thing they do is shoot it because it's going to back up water and it might flood the barn. Got to get them varmints out of there. So it's an old ingrained thing that it's in most people's genes that they're rodents, the largest rodent on the planet, I guess, or one of the largest. And so they're a varmint. So they might as well be shot or trapped. But the value they have to retaining water is, you can't beat it. There's no way. Okay, that's my spiel on beaver. Okay, any more questions?
Yeah, I have a quick question.
Yes.
So you said that this issue with the 12-foot ditch was caused by railway grade, right? And was that very common on the Palouse back in the, and then were there any other causes to like the same kind of ditch? It's like could you tell me what else would compel farmers to, well, like, because it seems like more like a very accidental thing. So like if I'm not mistaken. So.
Well, sort of, but it was deliberate. They built these rails deliberately to log. And in the early 1900s, up till about 1940, is when they stopped rails and they started trucking and they built roads instead of rails. But roads are also a problem. And when you're driving around, wherever you are, I don't care where it is, you're driving around, notice where they put roads. A lot of times roads, when you're driving down the road and you look, oh, look at that stream right there. They follow the stream. Why? Because, well, it's a low gradient. So you don't have to climb too steep. And that's for the railroads. They can't climb more, trains can't climb more than 3% grade. It's big. So they like these 1% and 2% valleys. They make perfect road beds. And we have a map that was done by a guy by the name of Tom Farbo. This is not, I don't think you can find this on the internet, but I could email it to Garrett. He could share it with you.
That would be amazing.
It's a map. It's called Logging Camps of the Early Days. And this guy, Tom Farbo, he worked for 30 years for the Forest Service out of Orofino. And he wrote a book. It's called White Pine Wobblies and Wanigans, which is about early day logging. And he has all the old logging camps identified. And all the old logging camps were basically supplied with a rail bed. And when you look at that map, it's from about headquarters over to the east out of Orofino, all the way to the Washington state line. And almost every valley has a rail of it.
Okay. Wow.
Okay, so like I said, they went up one valley, they logged, that's a drainage. So they took that drainage. Our drainage was 5.7 square miles. They logged 5.7 square miles. They pull the logs out, they pull the rails out. They go to the next valley. And what's the easiest way to get up that valley? We'll just follow the valley grade. It's low percentage. The train can make it, and build a berm and right up the middle. And then when they're done logging there, they just move to the next valley.
Maybe you should explain borrow ditch.
Yeah, borrow ditch, borrow, like you borrow money. Or you hear sometimes the term borrow pit. What they're doing there, the term borrow means you're never going to pay it back. You're borrowing it and you don't pay it back, and you borrow it from this dirt and you put it here. A borrow pit is a rock pit. So you see these rock pits around, they crush gravel. That's a borrow pit. And they take that gravel and they take it and put it under your foundation or your driveway. And they borrowed it from that pit, but they're never going to pay it back. But that's just the term where they take the dirt from.
That definitely answers my question.
Okay, so yeah, so
It was.
I would say it's,
Yeah.
and they didn't pay any attention to drainage
Right.
when they built these rails and roads. Their attention was the value of the timber. And it was like, what's the cheapest way I can get to that timber and get it out to the mill? It's a monetized thing. And that, I go back to the beaver. What happened to beaver? Why did beaver get removed from the system in the early 1800s? It was monetized. Beaver pelts were worth gold coins. So someone was cashing in on beaver. Native Americans didn't cash in on beaver pelts. They killed beaver, but they didn't kill them all. They killed for what they needed to stay warm in the winter, to make a coat or sleeping garment or whatever it happened to be. But they knew they had to keep beaver going.
And also explain about draining the fields for agriculture.
Yeah, and then once European man shows up on the scene and homesteads a place, what's the first thing you have to have? Water. Like we talking to a guy just a couple of months ago, and he says what he tells landowners about water in these restoration projects is, he says, you have this property here. Your property is worth nothing if it doesn't have water. If you don't have any water, you don't have anything, because no one can live there. Everybody has to have water. And this work you see going on right now is mostly salmon-based restoration. They haven't quite caught on to the fact that keeping water up in drainages is not only good for the salmon, but it's good for the aquifer, which we're all sucking off of. Every one of you has a straw here in the aquifer living in Moscow. Every time you turn on the water, it sucks a little bit out of the ground. Is that my chime for I'm done?
No.
Oh, I went over 5 minutes. Any more questions? Okay. Oh, I know one more thing I could say. We said we were beaver believers. We're believers in beaver. There's a movie called The Beaver Believers, which features a hairdresser named Sherry, and she likes to take shots of tequila, and she loves beaver. And it's a good movie, and it has a funny line to it, but it's all about stream restoration and the value of beavers. Okay. If you ever get a chance to see it, if you would like a showing sometime, we could show it to you. We have a Blu-ray copy. It's a good 40 minutes. It's not that long. Okay, I'm done, Garrett.
Awesome. Let's give him a round of applause. Thank you.
Thank you. Thank you, guys.
Yeah, we're about done here.
Okay.
You guys want it, we can set up a time to actually tour the site and do some volunteer work out there. We can do that a little bit after the meeting here.
Okay. Okay. Yeah. No problem. Thank you all for coming. Appreciate it.